Okay.
Let's see, there's Mr. Lane. Hello, Mr. Booker. How are you?
I don't see anybody else in here.
Nope, I've got Lane is talk.
There you go.
There you go. Yes.
All right, now I can you
Now
hear
I
me?
can. Yeah, I can. I had to turn your microphone on.
All right. Well, you can't see me apparently.
Yep. Nope. But we can hear you, and that's important.
Yeah, I'm not
Stacy's
presentable
here.
today anyway.
Yeah, that's
It's casual Friday, you know.
Hello, Stacy.
Can you see me?
Hey, Stacy.
Can you hear me?
Yes, very softly, but we can hear you.
Can you see me?
I think Luana may be on vacation down in the Caribbean, so when we get ready to do our formalities here for the nominations, we'll have you call the meeting to order once we get a quorum here.
Are you talking to me?
Yeah, since you are PE.
Okay.
If she's not here, we can just have you call the meeting to order, and then
Okay. I don't know why my
Yeah.
camera's not showing.
Huh.
Well, another thing Luana wanted me to mention was that I need an invoice so I can pay you the sponsorship.
Oh, okay. We can have and thank you for that, by the way. That's exciting. Glad to have you. We can get with Daniel, our chapter treasurer. I know he was
Okay.
traveling all over this week. We can have him take care of that.
Perfect.
So, and Stacy, I was talking to Thad earlier this week on something. I know he's going to be here too.
Excellent.
And I will take minutes.
There's Mr. Thad now. Hello, Mr. Goodman.
How do you do?
We're doing.
Good.
We're doing.
I'm multitasking, so please forgive me if I don't join on the video.
Okay. Sounds like you're driving. That's better.
That's why I'm not going to join on the video. I am driving.
Yep.
I'll listen until you need me to talk, and hopefully
Yeah.
talk.
We'll get the chapter business formalities out of the way here in just a minute. And then at noon we will turn it over to Dean White there with Cosentino. I did talk to Daniel the other day. He helped me figure out what I was doing wrong to get back into the Zoom. So I think he will be here as well.
Oh, by the way, I did invite one of my coworkers to do a little bit of a ride along. He just joined us, so
Excellent.
I want him
All
to
right,
sit in. Okay.
Glad
Great.
to have him.
Thanks.
I'm so used to doing Teams meetings,
I just
not
want to get on
Zoom as much.
all I want.
Is there any reason why we do Zoom over Teams?
Probably because we've always had Zoom.
Okay.
I know some regions, some chapters do Teams.
Just curious. I can roll with it.
You're flexible, right?
Yeah, I am flexible. I like in this situation though, I don't know where to go to find my camera because it said a minute ago that it was going to show and it's not. So it doesn't really matter. I just actually
Is
found
your is your little camera slider on top turned on?
it is on. Yes.
Oh, okay. All right.
Yeah.
Gotta love technology.
I don't know that we have the ability to turn on our cameras because we're
Oh, you know what? You're probably
attendees,
right.
not
Oh,
panelists. I think you guys are
Oh.
panelists.
Yep, that
Got it.
is correct. That is correct. Good
Thank
job,
you,
Lane.
Nice. I'm impressed.
Lane will
Not
figure
my
it
first
out.
rodeo, man.
Yeah. Okay, well we've got about 10 minutes before we turn it over to Dean. I do believe we have a quorum with 4 people.
Okay, well, we have a quorum. It is 10 till the hour. And so I will call the meeting to order.
Okay.
And Lane, would you like to take roll?
Well, I can't see, I don't think, who is here. So Mark,
we
can
have
you,
from the board, we have myself, Mark Ogg. We have Secretary Lane Booker, President-elect Stacy Sire, and Director Thad Goodman.
any other chapter members?
We have Brian Schwingel, SCHWINGEL. Attendance. And we also have our presenter of the day, Mr. Dean White.
Okay. So we have a quorum, I guess.
We do have a quorum.
Since the quorum is any number of chapter members.
Okay. All right.
Brian, we're happy to have you today.
Okay, so Stacy, I can take the nomination topic if you would like.
That'd be great. Thank you,
Okay.
Mr. Nominating
So
Chairman.
so everyone that is on the call, I am Mark Ogg. I am current immediate past president of CSINext, head of the nominating committee, and today I would like to formally nominate two individuals that have expressed interest in joining the CSINext board of directors. Those two individuals are Mr. Thad Goodman, who would like to be considered nomination for secretary, 2-year term starting July 1st, 2025, and Mr. Brian Miller, who is interested in being nominated for the open director position, also serving a 2-year term starting July 1st, 2025. Those are my two formal nominations. I will ask if there are...
Mark,
Yep.
you have another office that is going to be vacant. When Stacy moves from president-elect to president, you're going to have a vacancy in the office of president-elect.
Also correct, Mr. Booker. Thank you very much. Forgot about that. Yes, and we will have the open office of president-elect, which will serve a 1-year term from July 21st, 25 through July 1st, 2026, and then assume the presidency for the fiscal 26-27 year. That individual I would like to formally nominate for that open position is Lane Booker. And I believe that takes care of all formal nominations at this time. I will open it up to nominations from the floor. If you have one, please raise your hand and I will turn your mute button off. Okay. Stacy?
I'd move to close nominations from the floor.
I will second.
Who seconded?
I did, if I can.
Okay. Thank you.
If not, I do.
Thank you, Thad. Okay, Stacy, I believe we're ready to call for a vote.
Okay, all in favor of the nominations that have been brought forward? Say aye.
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 And all oppose, say nay. Okay,
All right, thank you.
thank you.
So we are Lane, that counts as we are affirmed.
Since there was only one candidate for each office, they are considered approved by acclamation.
Excellent. All right. Stacy, I didn't have anything else as far as chapter business. If we want to close the chapter business portion of the meeting, we can, and reconvene in 5 minutes for Dean's presentation from Cosentino.
Thank you. So I assume there's no other new business to be discussed or brought up?
Unless anybody has any, please raise your hand.
I'm leaving that up to Mark, since are you,
Yeah, I
like-
know, because I can see everything.
can
I do
see, but I
not see, I do not see anything.
Okay, well, for those of you that participated in this pre-meeting, thank you very much. We appreciate it. We are passionate about this chapter and excited about the next year and appreciate your participation. With that, then we can take a 5-minute, I move that we adjourn the formal meeting and we take 5 minutes and then we log back in with Dean and get ready for our presentation.
I will second that. Right.
Thank you.
Okay, see everybody in about 5 minutes.
Right, thank you.
How do I pause?
I'm just gonna stay here and make sure all the sharing
Yeah.
and stuff is fine.
Yeah, I'll pause the recording. All right. Hello, everyone. Welcome to the March program, exterior cladding innovation, Rainscreen design with ultra-compact surfacing. This is the CSINext chapter meeting for March 2025. I am Mark Ogg, current past president of the CSINext chapter, and today we are joined by Dean White from Constantino, exterior cladding manufacturer, and Dean is the regional facade or the regional facade manager for North America. He is based up around the Toronto, Canada area. So Dean, thank you for joining us today. Happy to have you here, and excited you are also one of our newer chapter sponsors. So thank you very much for that. I know everybody's pressed for time. It's the end of the week, so I will turn it over to you and let you introduce yourself and your team and get us started. For those that have questions during the presentation, there is a Q&A box on your dashboard there. If you could just enter your question in there, and we will get it answered as soon as we can. If it's something pertinent we're talking about at the time, I'll ask Dean to pause and take it then. If not, we'll probably hold all questions till about 15 minutes to the end of the session. So Dean, all yours.
Great. Thanks a lot for the introduction. I'm happy to be here. I'll just give you a quick background on Cosentino. So Cosentino, there's a couple of Italian brothers that moved from Italy in the late 1940s to Spain and started a marble business. We're still in the marble business today, all these years later. We are the developers of quartz countertops, so that's another hard surface that we make. And then in 2013, we introduced an ultra-compact material called Dectin to the market. So we manufacture in the south of Spain, and we have granite natural stone quarries in Brazil. We're in 120 different countries of 6,000 plus employees. In North America, we have about, I think, 2,500 employees. Half our sales come from North America and the other half around the globe. 300 salespeople with boots on the ground, about 80 and 90 they're architectural reps. So we've got a big footprint. We go direct, and we're in all the major cities with warehousing and showrooms, and are working the architectural sales community with all those boots on the ground. So today we're going to talk, we're going to go through the AIA CEU for exterior cladding with ultra-compact surfacing. Ultra-compact surfacing is also referred to as sintered stone, sintered compact surfacing, ultra-compact stone, and even a couple other names. It is basically a material that is like a porcelain on steroids in layman's terms. Okay, so we're going to go through, we're going to talk about what it is. We're going to talk about how you can get it on the, how you can get it in the wall in different Rainscreen and curtain wall type applications, and go through from there. So obviously the facade is a big part of the aesthetic of the exteriors of the building, and there's many different types of facades giving you different looks. This material class, the ultra-compact surfaces, they are a modern type looking. So they're a dead flat material. So you end up with very modern looking buildings with this type of material. And it has very unique physical properties, which we'll talk about in a bit. But, you know, from a design aspect, that's what you're looking at. And many, well, not many, one of them is a carbon neutral product, but many of them are very advanced in their sustainable approach to manufacturing. So it's a sustainable type material. So obviously it doesn't fit into the old molds of brick But we do have in this material class many stone-like materials that are mimicked with it, and you can get many different geometric shapes. This material is dead flat, so you don't have curved surfaces. So if you've got a curve you got to do, it's going to be a segmented curve with this type of material. So I'm pretty sure you all know what cladding is. It is basically what's sitting out in front of the building and giving it the look, but it's also what protects the building. So there's many ways to get this material on the building. It could be in a ventilated Rainscreen application. It could be direct bonded, just like vertical tiling. It can go into window wall and curtain wall and modular wall. But essentially, at the end of the day, it is a facade. And many of these different materials have different properties and budget points that they hit. There are pluses and minuses with all the materials that are out in the marketplace. The Ultracompacts are highly durable, UV stable products with very low life cycle costs and very long lasting products compared to some of these others. So what is it? It's a new product category relative to the marketplace. So it's been on the market since about perhaps 2000, maybe a little bit before 2000, where you started seeing these materials come to market. And there's maybe 5 or 6 primary manufacturers of Ultracompacts out there, and they're not the same as porcelain, but they fall in the same category. And many of the test standards are the same for the material. So there's a lot of ceramic type test standards that come into play with it. These materials are UV stable. So what you find with these materials is they can be used in every application where there's a hard surface. So you see them on countertops, flooring, interior wall cladding, shower pans, exterior pedestal decks, outdoor kitchen areas, and you see them on facades. So it's a very versatile product. I like to call these products unique and universal because you can use them everywhere. So from a design aspect, it means that you can have the design flow from the interior to the exterior and vice versa. I'm an exterior guy, so I like it when it flows from the exterior to the interior. So all the interior designers aren't thinking they're driving everything. But anyways, interior wall cladding can be applied in many different ways. You can use it where there's heat sources. It's not going to damage it. These are highly heat resistant products. And on the exterior, of course, you can use it everywhere there's a hard surface, like I said. And here you've got flooring continuing out onto the pedestal deck outside, into the pool. You can use this material, and of course on the cladding. Here you've got pedestal decks out in front of the airport in Azerbaijan. So that is ultra-compact surface on that pedestal deck. And the reason I talk about these, we talk about these materials being so flexible is when the building's being designed, there's a lot of scope that these type of materials can be used on. And that allows the designs to be tied together on projects. For instance, you could have your podium deck being done with these pedestal type applications. On the exterior cladding side, it's got some unique physical properties that allow it to be ideal for exterior cladding. So the first thing is it's non-combustible. So you can use it in non-combustible construction, and there's testing to ASTM E186, E84. There's some NFPA 285 testing. There's a Miami-Dade N08 testing that's done with these type of products. Non-combustible, very durable, very high scratch resistance. There's 7 on a Mohs scale predominantly, which means it's diamonds or topaz to scratch them. So they're very resistant to high traffic areas. Particularly, you see them used a lot in transit stations, urban environments, etc. Very low maintenance. So this product, because of the way it's produced, it's very non-porous. So it's graffiti proof, basically. If graffiti gets on this, you can wash it off with soap and water, a pressure washer. You can use harsh chemicals on these materials because they're very highly chemical resistant. So not only, on the facades, and worrying about graffiti and so forth, but they're perfect materials for laptops in buildings as well. There's a lot of different options to get it on the wall. You've got ventilated rain screens, you've got curtain wall, window wall, and you have vertical tiling. Now, most manufacturers in this segment are very focused on sustainable manufacturing, and you want to look for the kind of practices that they're chasing. Okay, so water recovery and reprocessing, The water recovery is key because this type of manufacturing use a lot of water as they break down the minerals and mix them in water to get them down to a certain particulate size. And then they dry that out, leave enough humidity in there to form a slab. So water recovery is very key because most of the climates that they're manufactured in, like say the south of Spain, are very dry. Think of the same areas where like the Clint Eastwood spaghetti westerns were filmed back in the days. That's how dry it is. Dry creek beds, dry river beds. So you want to conserve water as best you can. And in some cases, up to 99% recovery of the water or retention of the water. Dust recovery, reprocessing, using the production fall off and reintroducing it back into material so that the raw material waste recovery is a big focus with a zero waste model is what the target is. So every bit of raw material that comes into the factory, the goal is to have zero waste. If it doesn't get used in the primary product, then does it have a secondary use or can it be reprocessed so it can be reintroduced? Okay, things like automated transport systems, robot sleds moving the slabs around. Robot sleds are sustainable because they control the emissions. They go from point A to point B, unlike me on a forklift where I might go 100 feet over one way to talk to somebody and zigzag my way to my destination. They don't have any friends, right? So they just go point A to point B. And carbon neutrality is very key. And how you get to the carbon neutrality is in some cases, how you get there is by buying credits or investing in other programs or making use of the best available technology in order to bring down the emissions. These production lines are about 1 kilometer long, so about 0.7 of a mile, something like that. So it's very intensive manufacturing, and the final process that happens with these materials is they go into like 200-meter long ovens and they get heated up to a liquid state. And then they cool and everything bonds at the molecular level. Those ovens run off natural gas, and the goal is switching them to hydrogen. And just as a point of interest there, I thought when you switch to hydrogen, you kind of like flip a switch and you go to hydrogen. In fact, what you do is it's a graduated process where you blend the natural gas and hydrogen, and you kind of go in that way, make the switch gradually. So sustainable design, of course, is important, and thinking about all the types of things the materials you're using have low embodied carbon, or the embodied carbon that is there is offset, so that you can get the carbon neutrality, maximizing lead points, etc. And these materials all have various lead points that can be earned. Are they following, green building standards, third-party global standards, EPDs, HPDs, all these different types of standards that are out there? Really key, especially around, efficiently using resources, the occupant health and safety parts, improving productivity, and of course, reducing waste, pollution, and all the emissions and getting those materials around the globe. So, I'm going to blow by some of this pretty quick, but obviously it's been proven that healthy buildings allow for better concentration and better productivity. So anything you can do to keep the building healthier and having no things like off gassings and such in the building are very key in keeping it healthy and the indoor air quality up. These materials are also very good because they're completely inorganic. And there's nothing for anything to feed on. So you can't get mold development with this type of material as an example. That's really key in one of the physical properties for these materials. Many different certifications, Green Guard, HPDs, like I was talking about, European standards, North American standards, global standards that are met with these products and have certifications like Declare and the different ones that you see around the globe. On the lead, you can earn up to 10 lead points, if I remember correctly, with these type of materials. Of course, lead has changed a lot over the years, and if you're in the specification business, you probably know this better than I do, how it's changed from getting all those points for a bike rack that would equal the same as making the building super energy efficient. I think some logic got in over the years, and there's been some good adjustments to the lead standards and the ratings. So extraction of raw materials is really key, keeping the emissions down in the transport of raw materials, and of course, making use of the raw materials and not having that waste. So these are inorganic materials. They're minerals that are mined out of the earth. The minerals have gone through millions of years of the metamorphic process. And what happens is they're mined, they're pulverized down, they're mixed in water to make a certain particulate size, and they're reconstituted into a slab format. So what's really important to know about the Ultracompacts is they're not an extruded product, so you're not going to have profiles and so forth with them. They're a dead flat product. So they're reconstituted, and those materials, these inorganic materials are reconstituted. They're stored in silos, and they take the moisture out of that material and leave just enough humidity to form a slab. And that slab will go down the production line, and the first big station they hit is a press. And different manufacturers have different pressure that they press at. This one here you're looking at is 25,000 cubic tons, which is about 2.5 Eiffel Towers. So that makes a very ultra compact material, and that's where that ultra compact name comes from. Okay, that then will move down the production line, and it'll hit different decorating stations where mineral pigments are dropped on. Of course, all inorganic. So mineral pigments get dropped on to make the colors and the patterns. And then the final stage is going through those 200-meter long ovens where it gets heated up to just about 2,200 degrees Fahrenheit, liquid state. And when it cools, it's all bonded at the molecular level. They're all aligned, and it gives more physical properties to this material class. So the performance attributes, the UV resistance, these materials will look the same 40 years down the road. If they're in an environment where they pick up grease or something like that, or you can just wash them with pressure washer or soap and water. You could use harsh chemicals if you wanted to, but it's not going to damage the material. And so that UV resistance is very key, and that's why you can use it everywhere. There's a hard surface. It's heat resistant as well. This is the same basic technology used to make tiles on the space shuttle back in the day. Okay, what's changed since then is much larger formats, much different colors and patterns rather than just black tiles. And it's a very heat-resistant, non-combustible product. If you light it on fire and put like a fuel source on top of it, light it on fire and put it out, it's cool to touch almost right away. So it dissipates that energy. So the flip side of that is it does not have much insulating value. You're going to get your insulation value from your complete wall assembly. This here is, I think, 0.483 U value. So you're not looking for it to insulate. Stain and graffiti resistance I talked about, and that's because of the non-porosity. So unlike other material classes where you can get stain resistance by, and we understated a bit here with resistance, it's actually proof. But the other materials, usually they're going to get treated with some kind of chemical treatment, may discolor the material, and then you're going to have to reapply it over time as it wears off. These materials, it's because of the physical nature of the product, it's so non-porous that graffiti won't bite in at the molecular level. It won't get in there hard, so you can get it off with soap and water and a pressure washer, or even just a hand and a cloth. Okay, so extremely low porosity. That also means that it has very low water absorption. So if you look at the ASTM standard, the water absorption is 0.0%. If you look at the European standard, it's 0.1% that they list for these materials.
Dean, quick
Yes.
question. What type of materials can you use to actually clean the facade? Are there special things you have to use? Is it just
No, you can just use
special way to do it?
No, soap and water, pressure washer, or a hand, any kind of cleaning agent you can use on it. It won't damage it. They're very highly chemical resistant and stain resistant. So you can use their standard maintenance, but it's very simple. I mean, you can literally clean it with soap and water.
Great, thanks.
Very low, because it's relatively inert, it has a very low coefficient of thermal expansion. So when you're doing a facade, you're still going to leave gaps between the panels. The standard gap with an open joint system is like 8 to 10, so just 8 to 10 millimeters, a little bit under a half inch. like 3/8 of an inch, that type of thing. Although you can go as low as 1/8 of an inch with some of the materials and some of the install methods, because the building's going to move, the attachment system that's holding on the wall is going to move, so you still have to accommodate for that with the panels. But the panel itself is very, very stable. The sizing. Every manufacturer of this has different sizes. Here you see one example. But so when you're planning to work with this type of material, it's very important to know the manufacturer you're working on, what their slab sizes are. And because those slab sizes are going to impact your panel layout on the building, and it's going to impact the waste. So waste is one of the biggest cost drivers in a facade. Doesn't matter what the material is. In this case with Ultracompacts, if you've got a 5x10 slab, and you cut off 20% of it because you're making a panel that's only using 80% of the slab, and you can't use that offcut anywhere, that waste goes in the cost of fabricating that panel. So that's very, very key to understanding when you're designing the facade, what material you're working with, and can you make the most efficient use of that material to help keep the cost down. And slab sizes go as big as 4x12 or like 64 by 130 inches. 5-foot width of material is very key because that's what gets used a lot in unitized construction: curtain wall, modular wall, window wall, and that means you can glaze it in very easy in the opaque areas of the building. Thicknesses, the thicknesses vary in the industry anywhere from 3 millimeter, 4 millimeter, 6 millimeter, 8 millimeter, depending on the manufacturer. On the facade side of things, the most common sizes to use are 8 and 12 millimeter. 12 millimeter is 1/2 inch. And then you do see 20 millimeter, which is 3/4 inch, used a lot by stonemasons because they like thicker material. The panel people and the curtain wall people like using 12 and 8 because it's lighter and less costly as well. 7 on the Mohs scale, diamonds, topaz will scratch it for itself. Color stability. So the manufacturing processes are very tightly controlled, highly automated, very consistent. But when we talk about color stability, there's a couple things to note. From batch to batch, it's quite stable. Obviously, it uses natural raw materials, but there's a lot of control on how they're blended and so forth. But one of the questions that always comes up with man-made materials and engineered materials is how much variation is there in a slab of material? And that is never going to be the same as, say, natural stone would be. But the variation gets built in by taking this digital image that comes from the computer station that feeds the mineral printers that are dropping the mineral pigments. There's an image that starts, and then the first slab gets that full image. The next slab comes along, that image gets shifted, and it gets shifted, and it repeats every 8th slab, or that may vary by manufacturer. So that's where there's some variation that goes in. And then the other way you get some variation is by adjusting your layouts on the wall and placing the panels that way.
Dean, on variation, and you might have mentioned this, or you're gonna maybe mention this down the road. How does it react with temperature fluctuations compared to other types of facades? Is there a lot of movement? What needs to be
very little
considered
movement of the there's very little movement of the material itself. It's very, very stable. It's relatively inert, so it has extremely low thermal expansion. Okay, so it's not the thing that's going to move. It's not going to discolor. You're not going to get things like oil canning or things like you can get with some other materials where you might get some buckling if they haven't installed it correctly. Very, very inert, very dense product, extremely dense product. It's actually very similar to glass. Okay, as a comparison point. Yeah.
Thanks.
Yeah. You have the ability with these materials to do custom colors and designs. And these things are normally done for a minimum square footage, and it depends on the manufacturer what that is. It could be 30,000 square feet, could be 40, and there's somewhere it's 100,000 square foot minimums. This often comes into play, obviously, in larger jobs. And the ability to do customization, you can see, is is quite interesting. You see a couple examples here on the screen. The customization, it's a bit of a longer process because you got to go back and forth as you fine tune it, but it gets done quite often on larger jobs. You can do fluted type designs. You can do engraving, kind of mill it. This is all milled. Normally, these things are done after the slab's been made, and these are very dense products. So doing this type of milling is slow and expensive. But what's being experimented with, particularly when you see those flutes on the left, is to develop custom plates, because how you put texture into the material is you put a different plate on that press station that's there. So developing custom plates to press like flutes into the material is now being experimented with, so that you don't have to worry about all that slow milling that adds to the cost. You're just going to press a texture in. And of course, you can do digital imagery on there. And this is done exactly the same as all the other colors. It's done after the slab's been pressed, and it goes into the decorating stations and before it goes into the ovens, which means it has all the same physical properties as a standard product. It's UV stable. It won't scratch off. It won't wear off. It'll look the same down the road. This is a little bit of a poor example on the left, real early mock-ups, but the job with that, it was about 5,000 square feet of banding on a building that kind of wraps in a sequential way with 27 different panels that range from like 3 feet to 8 foot in length. So you can do some pretty interesting stuff that have to be sequenced exactly as well. And you can see also the imagery over on the right there. This can also be done, I'll just mention, this is not this is photographic imagery, basically, and you can get very photorealistic images. You also have the ability with the marble type products for book matching and so forth, if that's what the look is on the facade. I want to make a comment about patterns that have direction to them, like veining and so forth, or say a travertine, that type of thing. You normally have more waste with those colors and patterns, because when you make an offcut, it's often you can't reintegrate that offcut piece into the facade someplace because it won't fit with the direction of the layout on the building. So that always has some more waste when you're using patterns with direction. So the different Rainscreen applications, obviously on the Rainscreen side of things, you're looking at energy efficiency. You're looking at beautifying the building. You know, you're hanging off the building, so technically it's a curtain wall at the end of the day because it's not structural. You've got energy savings because of the wall construction that you're doing, the outboard insulation that's included, all the different things you're doing to control, with thermal breaks and so forth to make the building more energy efficient. You also get acoustic insulation out of it, so you get some sound deadening. You're protecting it against water infiltration, depending on what type of system is being used, whether it's an open joint system or a closed joint pressure equalized system. Then you have different levels of protecting the wall and the substrate from moisture infiltration. And of course, you've got thermal insulation like I started with. Unlike a single skin facade, with the Rainscreens, you are moving that interaction out and away from the substrate and the wall structure itself. And that limits the activity of things that are going on at the wall and protect the wall better as well. And these type of materials, they don't suffer from freeze-thaw damage like, say, some laminates do. They don't have to be sealed when they're cut. They don't have efflorescence like you see with cementous products. And of course, there's nothing for mold to feed on with these materials either. So they're very, very good options for hospitals, labs, data centers, that type of thing. You've got the drain back ventilator like we talked about. So very simple. There's a lot of attachment methods on the drain back ventilator side, mechanical or chemical structural adhesive attachments, but they all follow the same principle of drainage and ventilation. And you've also got pressure equalized options. So the drain back ventilated, that's what I refer to in layman's terms as a open joint system. So it's going to be open at the top and the bottom and between the panels, and the water is allowed to get in there, but then it'll drain and it'll dry. Typically, you're going to be using mineral wool insulation in these applications because They can handle water and keep its R value, but other insulations like polyiso and so forth are used as well. And the pressure equalized system, the simplest way to think of a pressure equalized system is think of an aluminum composite metal system that you see in wide use. That's where the panels are compartmentalized from each other. So they've got like an ASTM fire rated strip that goes between the panels, and it creates an air dam, and it compartmentalizes each panel separate from the one around it. In the technical testing, they got to do the AMA testing. The pressure has to equalize behind the screen to the exterior of the screen in 0.08 seconds. Can't be any streaming water. Different parameters you have to test to for a pressure equalized system. So that air chamber is obviously the most important thing, and these systems can vary in depth. The flexibility you have with a Rainscreen is really, really important, because on a new building, we know that it's never built the way it's drawn. So you have some variations there, and you can make up for those variations with a ventilating Rainscreen by adjusting the subsystem to account for things that are out of plumb, maintaining the cavity that you need for the insulation that you need there. You always have to have the air gap in front, obviously. So that's what's really key about using these panels, is there's many different Rainscreen methods to get it on the wall. So you've got energy savings, you've got acoustic insulation, you've got the systems are normally built in with thermal breaks, and that help with the energy performance of the building, protect water filtration, protect the structure, and of course you've got thermal insulation. Geography, you can use them in any climate. These particular materials you can use in cold climates, funds that have thermal shock during the day. Very hot climates, none of it will affect it. Okay, I'm a Canadian, so we still have to remember there's a whole bunch of facades going on north of that border there too, if you happen to do any work north of the border, if you're from Canada, and widely used in every climate. So on the concealed fastening system, one of the most popular methods is with what we call an undercut anchor. And there's a couple main suppliers of undercut anchors on the globe. Kyle and Fisher, they're both German companies, have been at it since about 1990. Tens of thousands of jobs done all over the globe. This anchor system is used with all kinds of large format panels, including natural dimensional stones, etc. So it's a very versatile system. You can go to unlimited heights with it. All you end up doing to combat the wind loads and to get the performance you need is add more attachments, so it'll perform. Okay, so you've got a thermal clip, you've got a vertical rail, you've got a horizontal rail, horizontal profile, then you've got a clip that goes into the back of material, and that clip hangs off of that horizontal rail. And you make adjustments to get everything true and plumb. The thermal clips are normally adjustable, so you can get different depths, and they'll have adjustability with them, so you can get everything on the same plane on the facade. Here's a good example here. These clips are normally the same profile as a horizontal rail. They just cut them off and flip them over and marry it to them. Then there's a set screw, you kind of align the panels, and then there'll be another screw, or one or two screws that'll go in here and into the rail to stop the panel from shifting left or right. Here's a kerf system. This is another system that's used a lot with, say, natural stone and some other large format panels. What you have is a groove that's put in the top and the bottom of the panel. In that groove, there's a rail that sits in there that acts as the horizontal rail and the clip at the same time. Okay, and when you're doing this, you have to put silicone in the top grooves in climates where you get water and freeze thaw, so that you don't get water freezing in here and then cracking the kerf. The minimum thickness for doing this is 1/2 inch, because that is a 4 millimeter wide. If you tried using like a 3/8 material, you would not have enough meat on either side to stand up to the pressures. And of course, you can do direct adhered. There's a couple different types of direct adhered. One of them is a chemical adhered, where it's literally a structural adhesive like you use in glazing, that you attach it to vertical rails. The other way of adhering is the old style tiling, where you use thin set adhesives on a substrate, and you don't have a Rainscreen in that at that point. All you've done is tiled the exterior of the building. Face fasten rivets, very popular because it's budget friendly. And what you got is color match rivets. Normally this is done with 8mm material, the thinner material. And visible clips that are not very visible when you're standing way back from the building. These type of systems come into play primarily for budget reasons. So rivets and clips are budget friendly type systems. And curtain wall unitized solutions. Well, I'll talk about this once I get through here in a bit more detail. But basically, you can glaze it into SSG systems or captured systems. You can hang it off of unitized walls with those undercut anchors. There's many ways to integrate it into curtain wall, window wall, and modular wall construction. Here you got a good example of them installing a ventilated system, and this system is actually I'm not going to play the video because well, actually, maybe I will if it does play. Let's see, and I'll talk over it because we couldn't get the sound working. No, it didn't. Oh yeah, it will. There we go. So here you can see a very standard Rainscreen system. Okay, I'm just going to turn my volume down a little bit. What you see is a very standard Rainscreen system. And the most important thing is obviously the measurements in construction. That's the most important. This happens to be a concrete wall, but you will be fastening into the studs, steel or wood studs on the building, because this is not a structural system. It's got to go back to the structure. And you can see that they're putting on mineral wool. Many different ways to install the mineral wool depending on the subsystem. Then they're going to come along and put their vertical profiles, get them aligned. This is where we're going to start getting them in a true and plumb on the building, even if the building itself isn't square. Their horizontal rail. And then they're going to install it. So these materials, there's a mesh put on the back for fall protection in case it gets broken. And you see they put the anchor clips in there, and they do something neat. See that offcut of the rail? What they did was they took that to align those clips before they tried hanging the panel. Because now they're aligned beforehand. If they're all cockeyed, you'd have a hard time seating that panel. They're adjusting it to align it, to get it plumb and square. And there you go. That's a very simple system. Here's some case studies. And one of the things I stress about these materials is that you don't have to use the same thickness and the same attachment method everywhere on the building. So what we've got here is a couple different attachment methods. On the right, you can see it's direct bond. You can actually see the grout in between the panels, and then or the tiles, I should say. And then on the left here, it's open joint. It's undercut anchor that's being used. You can do 1/2 inch material down low where there's a lot of contact, and you can move to 8mm above where there's no contact. So you can hit different budget points for the facade on it. That'll help bring down the budget costs, and you can use different attachment methods as well. You could use concealed fastener down low and go to face fasten rivet above, up and through the towers of a building, etc. You're not going to see them. You're going to see the same color flow up and the design flow through the building, but you're going to help keep the cost down. Here's a building in Vancouver, 8X on the Park. The flat white areas are Ultracompact. The fins are not. They're metal. But you can do fins with Ultracompact. You have to take two pieces and glue them together because they're only finished one side. And then you mechanically attach them back through the panel joints. So you can make fins with it as well. Here you've got an example of this book match project up close. Here, this drives some of my point here, although we don't see it. What you've got here is the Missouri Tiger Stadium, the entrance. This is the same color. This is like a flat kind of brown black, and this highly polished area is the same color, only mechanically polished. So that's the level of polish you can get on there. And these little triangle shape or little diamond shaped panels are much more costly than the bigger ones above, even though it's the same material. Down here, you've got a lot more hardware because every one of these has to attach to something, and you end up with more undercut anchors because there's a minimum amount of undercut anchors you'll have in a panel. So more dollars per square foot here, less dollars per square foot up here. That's the general rule of thumb. Here again, you've got all these balcony slab edges being clad with Ultracompact and with undercut anchors. Here's a really good example of a job that is actually, if you look at the job, it's a window wall job, except that there's no opaque surface in the window wall with the Ultracompacts. The Ultracompacts are wrapping the slab edges here and these little kind of soffit areas. And down here in the building, it's a unique building because it's flipped on its head. These panels are brought together in this X shape to provide ventilation to the mechanical on the building, which is down here. Above is all office and a luxurious restaurant on top. And this is a really good example of a very typical type install. Here's a low-rise multi-residential that was installed with undercut anchors. And we unfortunately can't see the bottom part where there's more that are vertically orientated. And this recessed and proud type look you get by adjusting the subsystem, not by using different thicknesses. And you can see what happens is you get this dimensional look by having a thin material that you put returns on to give a dimensional look. And this is not, I don't really like this diagram of this Raffendale Academy, but Raffendale Academy is a place that has 400,000 square feet of Ultracompact on it. There's also a big custom blue. The big chunk of the facade is actually custom blue. And then the pool, the pedestal decks, the flooring, the wall cladding, the vanities, the whole place is covered. The hardscaping is all covered in Ultracompact surface. It's so versatile. Many different colors other than what you see here. Here's a good one, Southern First Bank. This is 3/4 inch material that's put on there with undercut anchors. You can see it down in these columns here. So that's kind of the, how am I doing for time, by the way?
We've got
I'm doing good.
about 18 minutes left. Got a couple questions, not too many. So we got a few more.
Okay, good. Well, this is the slides for the CEU part. So let's, I'll take some questions down, then I'm going to share some other material after I take the questions. It'll give you much more detail. Okay?
All right.
All right, go ahead, fire away.
Okay. So one question, field quality control. What type of I guess methods, practices, what's used in the field during install that you've seen as far as control and making sure, because obviously, you know, with this stuff being on channels and bolted, you know, it showed the gentleman there using the level to make sure it's straight, plumb, square, all that. What kind of quality control measures are recommended?
The quality control members, so most of the manufacturers of this material, some may provide the attachment system, but most of the attachment systems come from third parties. Okay, people like SFS, EOT, Fisher, Gridworks, the different people, Yukon, that operate in the marketplace that provide the engineering, the shop drawings, and the profiles and extrusions and everything to hang the material on the wall, where the manufacturer primarily provides, in most instances, cut to size panels with the holes of the grooves put in, driven by the shop drawings received by the installer and their attachment system partner. And the attachment system partners, of course, they'll do training. Oftentimes they'll come out to get the startup going on a project, and they'll walk through you know, the tolerances and so forth, and how their system is installed. Okay, from the skin, the Ultracompact side of things, then there's a quality trainers that go, and you can cut in access on site, you can cut material on site, that type of thing. You can drill holes in it, etc. And those quality managers will go around and they will train the people, the installer or the fabricator that's using installing, on how to work with the material, how to manipulate it. Okay, so that's key. In most cases, these systems are very widely used. All you end up with is like a different skin. So many of the installers, the cladding contractors, they know how to work with the systems, and they work with them on a regular basis. So obviously, if the building has inspections built in, maybe it's a third party building envelope consultant, but you'll find that the system manufacturers don't take on that role of actually designing the exterior envelope and of the building. Okay, that's driven normally by a facade consultant, because there's a lot of things there about, you know, waterproofing and etc. and how the tie-ins are going to work and so forth. And most of them will pick up. In some cases, they'll do the air vapor barrier, but most of them pick it up from there and then and outwards, if you know what I mean. Does that answer the question sufficiently?
Yeah, I think another one popped up. As far as I know, sometimes like on curtain walls and glass work and stuff, they do field kind of like pressure testing or making sure there's no penetration of moisture. Is there anything done on applications like this?
It's the same. Oh, you mean on Rainscreen type applications? Well, for instance, if it's a pressure equalized Rainscreen, then the design actually has to pass a test. So they do specific AMA tests for pressure equalized systems, right? But this is on the Rainscreen side. I'm just trying to think of what the test standard is for an open joint system. I think they follow the best practices and they follow what the facade consultants talk about. And the system partners, they have their parameters for installing, right? Talking about gaps, minimum gaps, how much movement there is in their system to make up for that. So, you see it get absorbed in the attachment system opposed to showing up on the facade itself and making things buckle or so forth. So I think if I got the gist of your question, when it comes to curtain wall and window wall, then of course, most of those systems, they go through pretty rigorous testing and they would take our material and glaze it in just like they would the glass, and they do their testing. And that happens all the time. You could create a mock-up, for the customer, but you also end up creating a mock-up to test that system because many of them are custom at the end of the day.
Okay. I got a question on building information modeling as well. Are the products, are there BIM models, Revit files out for the systems?
The answer to that is that I think it varies by manufacturer. For the material itself, what you see in BIM modeling is mostly the colors that come from the Ultracompact manufacturers, but the systems themselves, I believe some of them do. Like for instance, a Hilti. Hilti is very involved in BIM, and their attachment systems will have BIM, will have all the BIM documentation and integration and so forth.
Okay. I think we got one last one here. Do you have, can you talk about some of the installations you've seen, watch outs, difficulties, lessons learned from installs as far as applications in the field, what maybe some best practices, some watch outs for folks that will be installing these?
Yeah, so the real key thing is to understand the product and any kind of parameters there are with it. Okay, so for instance, and uses and thinking about construction schedules and what the impact of different systems have on the construction schedule as well. But there's a few things. Coming from the factory and cut to size, different factories have different parameters for things like the depth of a mitered return. So if you've got a window and you've got a return, then often that depth is a minimum 5.5 inches. That's because at the large factories, they use large material, and when you're putting a miter on a panel, if you get less than 5.5 inches, it makes the panel start to float. Now people can put miters and stuff that's 1 inch by hand or with smaller machinery in a local fabrication shop. But when you're going in on the big economies of scale, then you need to be cognizant of some of those parameters. What's the maximum slab size you can use or max panel size you can use based on the wind load of the building? What have you got for conditions on the building? Are there going to be mitered returns? How does that impact that design and how they're going to install it? The most important thing I would say, two things. One of them, when it comes to cost and budget, is that you want to look at the installed cost. You don't want to look at just the material, just the attachment system, or just the labor, because it's the combination of the three that's important. Okay, just a quick example. Sometimes it's cheaper on the wall to use thicker material than thinner, because the thicker material can span greater distances, means that there's less hardware, less labor to install. Okay, so that's one thing. That's one thing that impacts the decisions about what system to use. And then the systems themselves have different ease of install. Let's call it that. So an undercut anchor system is probably the most flexible system that you can use, because you can use it at unlimited height. You just end up adding more anchors. You can do soffits with it, etc. Okay, but it's one of the more expensive systems, because those anchors, I don't know what they are today, but I think they're around $3 an anchor. So they can really add up. I had a job that had 500,000 anchors on it. So just for anchors, that's not
Just
even the
for
hardware,
anchors.
right? So, understanding the system, and then when you're doing those type of cut to size with holes drilled and grooves, you're going to wait to order the panels until you've got the site dimensions. So the girts are up, you got your site dimensions, and then you're going to order. Then the lead time kicks in, and all these products come from overseas. And the lead time coming from Spain, for instance, to the East Coast is about 10 to 12 weeks for
Right.
once the shop drawings are finalized and the manufacturer going to production till the time it's delivered. So on the flip side,
You're
if you're
looking at
doing
easily, possibly up to 6 months.
that's right. And so because there's all the back and forth that's going on before you actually get those shops finalized, right?
Right.
So once they're finalized, you go into production, then the lead time kicks in. So then if you're going to do something like a chemical attachment, with the structural adhesive, then you could order slabs in ahead of time. You could get your measurement, get your framing up in the wall, get your measurements, and then you can just cut it local, and you don't have that long lead time. Or if you're doing a rivet system, the same thing. You could cut it local and drill it. You could do it on the job site, or you can do it in a shop. So that has a positive impact on the construction schedule. So the different systems have different pluses and minuses. A curved system, you can't do as large a panel, and it has to be horizontal. There's a lot of different things that come into play when selecting the system. Budget, ease of install, does it meet the design intent for the layout? Many different things to consider. And there's little tricks, there's little tricks on install too that the experienced people pick up. This is not a product, often sometimes, you might order the field panels, cut the size and leave the ones at the corners a little bit longer and trim them, because you don't know exactly where those corners ended up once they constructed it. So there's some ways to reduce the lead times, but that's a huge thing, right? Is construction schedule.
Absolutely. Absolutely.
Okay.
Okay. Well, I think that takes us right up to the end of the hour. I don't see any more questions.
I think we have about 5 to 10 minutes left, right? What have I got? Are we supposed to finish at
I've
1?
got 6 minutes.
Okay, well, let me just share a couple things with you
Okay.
then. Okay.
Sure.
So now we're out of the CU. I'll just talk about Decton in particular, which is the Cosentino product. It is a carbon neutral product, and it's the only one in its class that's carbon neutral. Okay, so that's really key. We work with it on a circular economy type model, zero waste, everything goes out and has an impact on something else. All right, and that we're designing from the beginning to be energy efficient and sustainable. That wasn't the case. If you've been around like I have for a few decades, you go back to the 90s, most people couldn't even spell sustainability, right? You just made a product, pushed it out to market. But I want to give you a few examples of products. The ability to customize is really key. Okay, so you have a lot of different custom colors that can be done, different textures and so forth. And the flexibility, let me just see if I can find my slide for that. That's a little bit further down. The flexibility in manufacturing. So in our case, we not only have 2 standard sizes, we have the ability to manufacture custom slab sizes. And this is huge, because we can take anything that's smaller than 64 by 130 with a set of widths and lengths and put together in different combinations to find a slab size that will reduce the waste. I had a job that had 38% waste with 64 by 130. We found a custom slab size, brought the waste down to 10%. So that's really significant, having that flexibility. Okay, that's a big impact on costs. And I did want to just show you, because it's interesting seeing this Toha job in a little bit more detail. So here you can see, this is phase 1 of that project. Here's how they installed the panels for that ventilated area, and they used undercut anchors to do it. Okay. And then they put mesh in there to keep the birds and stuff out. And that's where they're getting their ventilation for the mechanical. You can see the birds actually sitting right here and not going in.
Not
Where my
going in.
mouse is there. And then here, you get an idea of the overall project. That is this first phase right here. And now the 75-story sister tower is being installed. They used undercut anchors on here, and here they used honeycomb. So you take like 4 millimeter thick Ultracompact, adhere it to a honeycomb facer and backer, and create the panels from there. And another curtain wall job here where it's integrated, glazed in, down in Austin, Texas. That's the 80 Rainy job. And this was what I was talking about, the Majorca job. You can see the custom blue that we did for them. All these surfaces are decked, and there's 400,000 square feet. So that's what I got.
That is definitely some beautiful stuff. That is great application. So
Yeah, and we have 80 to 90 architectural of our own people. We have some independent agents as well. They're doing architectural sales and spec work, and we're supporting, we do a lot of work with developers, and that drives a lot of our business as well, because we have a huge interior component. I'm just a facade guy. I'm like the little tag on, we do a couple $2 billion a year, 90+% of it's interior work. And we leverage that to get exterior work out of a bunch of the people we do interiors on. But we're getting in every segment, healthcare, multi-residential, institutional, everywhere, transit, a lot of transit stuff, because it's a very durable product.
great. We do have one last question here.
Great.
Is it possible to get a copy of the slide presentation?
Absolutely. I'll share over a PDF. And of course you can, if you need AIA credits, you can do them, or we can do them as well. As long as we got the names, we can submit them.
Yeah, the
for CEU events.
that was one thing I forgot to mention at the beginning of the program, is that everybody will receive a survey link. Probably usually takes about 24 hours for it to generate. So it should be sometime over the weekend or by Monday from the Zoom meeting invite. And there you can fill out a survey on the presentation and put in any information that you need to submit as far as AIA, so that we can get that straight over to you, Dean. And then you will have email addresses and such for folks that would like a copy of it.
Great. And I guess I want to put out one other idea out there for everybody. I'm not sure what industry everybody's in, et cetera, but we love doing joint events with other people in the construction industry. We find that, it's a win-win type thing. We actually host events at our city centers, and we don't charge anybody for people to come into the events with us. So the other members, we pick up and cater the stuff, and people can give their CEU presentations. We'll do ours, and it's kind of a scratch each other's back and get the word out on different products to the architects and designers and so forth.
Awesome. Well, Dean, thank you. Thank you for joining us today. And again, thank you for being one of our chapter sponsors. Happy to have you. Great product, great information. Everybody, we will be convening, I believe it's April 11th for our April program. Keep an eye out on CSINext.org for that. And again, thank you all for attending, and have a great rest of your day. Thanks,
Great.
everybody.
Thanks for your time. Appreciate it.